Hi everybody, welcome to Old School Chemistry. We're going to talk about osmosis. I have three little definitions that I want to talk to you about and then three examples. Let's begin with the definition of osmosis. Osmosis is the passage of solvent, so mostly water, okay? Passage of solvent, usually water, across a semi-permeable membrane from a solution of low solute concentration to a higher solute concentration. This is going to feel a little anti-intuitive, but this example will help you. So let's have this be our container, and in the middle, that purple line in the middle, that's our semi-permeable membrane. Now these semi-permeable membranes, this is really in living substances, okay? And these membranes will allow small particles to pass through them, i.e. water. But larger particles like macromolecules, sugars, those can't pass through. Now you have a different concentration on both sides of this membrane. For example, on this side, notice I have 2 sodium ions and 8 water molecules. So that would give me a 1 to 4. So say 0.25, okay? 0.25 would be my concentration. On this, right here on my right-hand side, I have 4 sodium molecules and 8 waters. Ooh, this has a higher concentration. I have more solute for the same amount of solvent, of water. So this would be a 1 to 2 ratio. So we say that that would be a 0.5. Okay, so there's an imbalance. There's a concentration difference. What happens is that to reach equilibrium, there is a push toward the same concentration. But rather than, I mean, you and I look at this and go, oh, that's easy. Just pop one little sodium on that other side, and then we'll have a 3 to 8, done. But in semi-permeable membranes, it's not the solute that moves, it's the solvent, it's the water. And so the water will always go from the lowest to the highest concentration. It's trying to dilute that high concentration to bring them into the same concentrations. So this is my low concentration, this is my high concentration. What happens is that water is going to come over here and say, dilute, dilute, dilute. Got to bring that concentration down. So notice I circled 2 of those water molecules, put a little arrow. Those are going to diffuse through that semi-permeable membrane, and here's what we have. So I still have the same number of ions, the solute on each side. I've got my 2 sodium, my 4 sodium, but 2 waters went to the right side, so now I only have 6 waters on this side. So that would be a 2 to 6. So I'm at about a 0.33. Now over here, I still have my 4 sodium, but I now have 11 water molecules. So that ratio, 4 to 11, would be about 0.36. So it's getting closer. Now notice how I drew this. This side is beginning to bulge. It gained 2 water molecules, so it's going to take more volume. Now if this was fixed, the water volume would just increase. But with our substances that are living, the volume, they're going to begin to expand. They're going to get a stretch, if you will, get a little bit bigger. That volume will increase. So that's the principle of osmosis, that the low concentration is going to dilute the higher concentration to try and reach the same concentrations. And the way the dilution happens is the solvent moves. It's the water that moves through that semi-permeable membrane. Now this bulging right here, so it's taking up more volume because it's saying dilute, dilute, dilute. All this water is pushing toward that high concentration. That creates what's called osmotic pressure. So let me give you that definition. Osmotic pressure is the pressure that prevents the flow of additional solvent into the solution on one side of the semi-permeable membrane. So the low concentration begins to push the water, okay? It's going to move through that semi-permeable membrane to dilute the high concentration, but at some point, this can't expand anymore. It takes more volume until it hits a maximum volume, and then no more water can move through that. At that point, water will go back and forth, but it is going to still maintain that maximum volume. It will go back and forth, then it will maintain that volume because of the osmotic pressure. It diluted the maximum that it could dilute. That no more water can move, no more volume can expand anymore. Maximum volume has been reached. Now, a really big takeaway in all of this is that osmotic pressure, osmosis, is a colligative property, which means here, the greater the number of dissolved particles, the greater the osmotic pressure. So here is a great application, another example for you. If I have a 0.1 molar sodium chloride compared to a 1 molar glucose, so they're both 0.1 molar, you have to look at the dissolved particles. Sodium chloride, when it dissolves, breaks into 2 ions, sodium ion, chloride ion. So its Van Hoff factor is 2. It produces 2 particles for every 1 sodium chloride. Glucose, being a molecule, is not going to dissociate. So its Van Hoff factor is 1. 1 glucose is 1 particle. So sodium chloride produces 2 particles. Glucose only produces 1 particle. That means that sodium chloride has 2 times the osmotic pressure because it has twice the amount of particles. And it doesn't matter what the substance is, you're just counting how many particles dissolve. Now, another application inside of this, that the greater the number of dissolved particles, the greater the osmotic pressure. Let me give you another example. Let's say that I have the same solution, glucose this time, but it's a 0.1 molar and a 0.2 molar. So I'd have a 0.1 molar on one side, semi-permeable membrane, and a 0.2 molar on the other side. Here's what you and I would observe. The 0.2 molar glucose will have the highest osmotic pressure. Why? It's because the water, that solvent, is going to rush and dilute the high concentration, and so it's going to expand, the volume gets bigger, until we hit a max, and that's your osmotic pressure. Second thing, the water will flow from the 0.1 to the 0.2. The lower concentration dilutes the higher concentration, trying to bring them into the same concentrations. It's possible they'll never reach those same concentrations though, because of the volume max. The total volume will be hit, and then it stops. That's the osmotic pressure. Okay, so there's osmosis. Colligative property. The lower concentration always dilutes the higher concentration, and whichever substance has more dissolved particles, that is going to be the higher osmotic pressure. Those are your big takeaways. All right, have a good day. Thank you for being here.